Welcome to Balancing Equations. So you aren't always given the coefficients for an equation, and you might then need to balance it. But if you know the chemical formulas involved, then you can find the coefficients that balance the equation using trial and error. So because of the law of conservation of atoms, there is only one set of ratios that will balance a chemical equation. However, if you multiply all of the ratios by the same number, you'll still have a balanced equation. And thus, you may see a balanced equation with multiple sets of coefficients, but the ratios between those coefficients will be the same. For example, in the combustion of hydrogen with oxygen to form water, we have two hydrogen molecules, so 2H2 plus O2 yields 2H2O. But instead of having two hydrogen molecules involved, we could have one hydrogen molecule involved, in which case we only need one oxygen atom, and that means that we need half of an O2 molecule. And that then will produce only one water molecule. And note that the ratio between hydrogen to oxygen is still 2 to 1, it's just now it's 1 to 1/2, and if we simplify that and get this 1/2 back to 1, we then have two molecules of hydrogen again. So when balancing a chemical equation, follow these steps. Do not change a formula or a subscript. The only numbers you can change or add are the coefficients in front of our chemical formulas. To start, put a 1 in front of the most complex formula. This is the one with the most atoms or the most different types of atoms. And if two are equally complex, then pick either one, doesn't matter. And then next, add coefficients to the other side that must be true to keep the same number of atoms of an element on each side of the equation. And continue to add coefficients that must be true with a preference for the next most complex formula and working your way down to the very simplest form. In general, you're going to want to leave hydrogen and oxygen until last. And if adding a coefficient on one side requires you to change a coefficient that you've already added, that's fine. Go ahead and change it, and then you're going to have to look at that atom again and balance for that atom or that element again. So let's look at an example. Here we have a chemical equation with some blanks to indicate that we need to plug in some coefficients. So let's start out by putting a 1 in front of our molecule over here. So this is C3H7OH, this is propanol, plus O2, this is oxygen gas. This then yields carbon dioxide and water. So we're going to ignore the oxygen for a minute because that's a fairly simple chemical formula. It only involves oxygen, so there's only one type of atom involved there. Here we have carbon dioxide, this has 2 atoms in it, and here we have water that has 2 atoms in it as well, 2 types of atoms. And so our most complex is the propanol, so that's why we started by putting a 1 there. So if we have one molecule of propanol and 3 carbon atoms in each one, that means that for carbon here we have 1 times 3, which gives us 3 carbon atoms on the left. That means we need to have 3 carbon atoms on the right. Now we don't have any carbon in the water, so however many water molecules we have, that's not going to change the number of carbon atoms on the right side. We need 3 carbon atoms on the right. We have 1 carbon atom in each carbon dioxide molecule. We need some number to give us a total of 3. So 1 times 3 then gives us 3. So we need to plug a 3 in there. So now we have 3 carbon dioxide molecules. And note that by plugging that 3 in there, we've changed the number of carbon atoms on the right side, but we've also changed the number of oxygen atoms. So we're going to come back to the oxygen because the oxygen is actually involved over here as well. So we're going to go and balance for hydrogen. So let's look at hydrogen. Now we've got over here, we have 7 plus 1 more over here, so 8 hydrogen atoms in each molecule. We have 1 molecule of propanol, and that gives us now 8 hydrogen atoms on the left side because there are none involved in the oxygen. And on the right side here, we have none over here, and all of our hydrogen atoms have to come from the water then. We have 2 hydrogen atoms in each water molecule. So we need a total of 8 on this side, so we then have to multiply by 4. So we need 4 water molecules here to balance out our hydrogen atoms. And now let's look at oxygen. So on the left, we have 1 oxygen atom here, so that's 1 times 1, plus we have 2 oxygen atoms now in each of our oxygen molecules, so we have 2 times some number. And we don't know what that number is, but we're going to have to plug in something there. So this equals something, and we'll come back to that. On the right side, we have 3 times 2, so that's 6, plus another 4 times 1. So we have 6 plus 4, which is 10. So now, let's go back over here. So now we need to have something that equals 10. And we have 1 times 1, so 1 plus 2 times something has to give us 10. Now it doesn't matter what number we plug in there, we're going to get an even number out from this part. And then when we add 1 to it, we're going to get an odd number, so we can't get 10. Which means that we have to change one of our coefficients. So let's go back here and let's change this 1 to a 2. Let's make that a 2. But now we've doubled the number of carbon atoms and we've doubled the hydrogen atoms. So now instead of 3 here, we have 6, because now we don't have 1 there, we've got a 2. And we've changed from 8 to 16. So now that means that we need to change these values as well. So we need to change this to a 6, and we need to change this to an 8. And that means that now down here we have 6, we have 1 carbon atom times 6, which gives us now 6. And we have now 8 times 2, which gives us 16. So now we're still balanced for carbon and hydrogen, but let's look at our oxygen now. So now we have not 3 times 2, we have 6 times 2, which now gives us 12, plus over here now we have 8 times 1, so we have 8 times 1, which is 8, and so now 12 plus 8 gives us 20. So over here, now instead of 10 oxygen atoms, now we need 20, and instead of a 1 here, we have a 2. So now we have 2 times 1 plus 2 times something. So this is 2 plus something has to give us 20. So this term has to be 18, because 20 minus 2 gives us 18. If that term has to be 18, then we divide it by this 2 to give us 9. So we need 9 there, will give us 2 plus 18 equals 20. So that means that this 9 is now the number of oxygen molecules we need that we plug in there. And now our chemical equation is balanced. And let's clean this up a little bit. So we have 2 propanol molecules plus 9 oxygen molecules react to give us 6 carbon dioxide molecules and 8 water molecules. Now, suppose that we had a coefficient of 4 in front of our first formula, so in front of our propanol there. So if we have a 4, now we can go ahead and do the same steps. So we have for carbon and hydrogen and oxygen, we can figure out how many atoms we have of each one on each side. So carbon, now we have 4 times 3, which gives us 12 on the left. We now need 12 on the right. We have 1 in each carbon dioxide molecule here, which means that we need 12 molecules to give us 12 carbon atoms. For hydrogen, we have 4 times the 7 plus 1. So 7 plus 1 is 8. So 4 times 8 is now 32. So we need 32 hydrogen atoms on the right side. We have 2 hydrogen atoms in each water molecule, so 2 times something gives us 32. That something has to be 16, so we need 16 water molecules. And now let's look at oxygen. We have 12 times 2 oxygen atoms plus the 16 times 1. And so now we have 24 plus 16, which now gives us 40 oxygen atoms on the right. That means that we have to have started with 40 oxygen atoms on the left. Now we have 4 times 1 oxygen atoms over here from the propanol, plus some number times 2 from the oxygen here. And so we have 4 plus 2 times some number, giving us 40. Well, this second term has to be 36. 36 divided by 2 gives us 18. And that means that we need 18 oxygen molecules. So here again we have our balanced chemical equation. And note that our coefficients in the balanced equation are all divisible by 2. So 4 is divisible by 2, 18 is divisible by 2, 12 is divisible by 2, and 16 is divisible by 2. And if we divide them all by 2, then we get 2 propanol plus 9 oxygen gas yields 6 carbon dioxide plus 8 water molecules. But that's what we had that first time around when we balanced, which means that the ratios here in that original balanced equation that we had with 2 propanol molecules, those ratios between our reactants and products are exactly the same up here. So if your coefficients are divisible by the same number other than 1, then divide them. In other words, simplify your equation after you've balanced it to make sure that now these coefficients, the 2, 9, 6, and 8, are no longer all divisible by the same number except for 1. Note that 2, 6, and 8 are divisible by 2, but 9 is not divisible by 2. And that was balancing equations.